landing on the moon is not like landing an aircraft. There is no runway, no air to slow you down, and no pilot gently steering from a cockpit. A lunar lander arrives as a fast-moving machine, falling toward a world with weak gravity, hard ground, and very little forgiveness. That was the challenge facing Chandrayaan-3, India's lunar mission that carried the Vikram lander and the Pragyan rover to the moon. The final descent was the most delicate part. The spacecraft had to reduce its speed, control its angle, choose a safe patch of ground and touch down gently enough to survive. The moon makes this harder than intuition suggests. On Earth, aircraft use atmosphere, wings, GPS, signals, control towers, and constant human guidance. On the moon, there is no thick atmosphere for parachutes or wings. GPS. Satellites are not waiting overhead, and radio commands from Earth take time to travel, so a person cannot joystick the landing in real time. That means the spacecraft has to become, in a very real sense, its own pilot. It must measure where it is, estimate how fast it is moving, and decide how to fire its engines while the surface grows closer. Every second, Chandrayaan-3's success showed that this kind of precision can be achieved with careful engineering testing and a landing system designed to handle uncertainty. What scientists and engineers know is that the mission reached the lunar surface safely. What remains fascinating is the chain of split-second decisions that had to happen before the landing legs ever met the dust. The memorable idea is simple. A moon landing is not one final maneuver. It is a controlled fall that must turn itself into a gentle arrival. And that is where Chandrayaan-3's quiet intelligence becomes the heart of the story. Chandrayaan-3 could not ask Earth for every move during the last minutes of descent. By the time a command crossed space and a reply came back, the lander would already be in a different situation. So Vikram had to use an onboard landing system, a small, fast decision maker built from sensors, software, and engines. It did not see the moon the way a human pilot sees a runway. It read the moon through measurements. Some instruments helped estimate height above the surface. Others helped estimate sideways motion and downward speed. Cameras and onboard processing helped compare the approaching ground with what the lander needed, a place flat and safe enough for touchdown. The exact internal logic is complex, but the broad idea is beautifully simple. Measure, compare, correct, repeat. During descent, a lander is not just dropping. It is also turning, slowing, and shifting from a more horizontal flight path into a nearly vertical arrival. Its engines must fire with enough force to break the fall, but not so aggressively that the vehicle becomes unstable. If it drifts sideways, it must correct. If the ground below looks risky, it may need to adjust within the safe landing area. This is why autonomy matters. The spacecraft is operating in a place where human reaction is too late, and where every extra movement costs fuel. It has to follow a plan, but also respond to the real conditions it measures on the way down. What is known is that Chandrayaan-3's Vikram lander performed this final descent and reached the surface safely. What remains harder to appreciate from the outside is the speed of the judgment happening inside the machine. The takeaway is that autonomous landing is not magic. It is engineering discipline under pressure. Sensors, listening software, deciding engines, answering. And on the moon, that silent conversation can make the difference between impact and arrival. When Chandrayaan-3 touched down, the achievement was bigger than one spacecraft reaching the dust. It was a signal that the moon is becoming a place where more nations can attempt precise, science-driven exploration. The landing made India the fourth country to achieve a soft landing on the moon. It also placed Vikram and Pragyan in a high southern lunar region closer to the moon's south pole than earlier surface missions. That matters because the polar regions are among the most interesting places on the moon. Near the lunar poles, sunlight arrives at a low angle. Some crater floors may remain in shadow for extremely long periods. In those cold, dark places, scientists think water ice and other frozen materials may be preserved. That does not mean Chandrayaan-3 proved a future moon base is ready or that water is easy to collect. It means the region is scientifically valuable and worth learning how to reach safely. Chandrayaan-3 also mattered as an engineering demonstration. Every successful soft landing teaches future missions, something about navigation engines, thermal control communications, and how machines behave when Earth is far away. Even a short-lived lander or rover can help refine the next attempt. What is known is clear. Vikram landed safely deployed, Pragyan, and operated on the lunar surface. What remains uncertain is how future missions will handle the hardest polar challenges. Long shadows, steep terrain, brutal temperature swings, limited power, and the practical search for usable resources. The uncertainty is not a failure. It is the next frontier. Space exploration often advances one careful landing at a time, each mission turning a once impossible place into somewhere slightly more familiar. The memorable takeaway is this: Chandrayaan-3 did not just land on the moon. It helped prove that reaching difficult lunar terrain can become repeatable. And if the moon is humanity's next great testing ground, autonomy is one of the keys that opens the door.